Number one, we have this equation y equals 3x, and we're asked to convert this from rectangular to polar form. So what we're going to do is we're going to use these equations here, x equals r cosine theta and y equals r sine theta, to do this conversion. So what we're going to do is replace this y with r sine theta and replace this x with r cosine theta. So y is r sine theta. That's equal to 3 times x, which is r cosine theta. And now notice that there's an r on both sides. So let's divide both sides by r. And then these will divide to 1. So we're left with sine theta equals 3 cosine theta. And now to simplify this, we can divide both sides by cosine theta. And sine theta divided by cosine theta is tangent of theta is equal to 3. And we can leave that equation just like that. So the polar form of this equation is tangent of theta equals 3. Now, when we go to graph this, it's going to be easiest, even though we're given a polar graph, it's going to be easiest to use these the rectangular form to graph this, because unless we have a calculator to figure out what theta is, what the inverse tangent of 3 is not going to be terribly easy. And even once we do that, the calculator is going to give us a decimal approximation, and that's not going to be terribly helpful. So what we can do, though, remember to graph an equation, this is in the form y equals mx plus b, where b, our y-intercept, is at 0, and then our slope is 3. So we just have to, we're going to go up 3 and over 1. So we have to, now we're using rectangular coordinates, so we have to go straight across and straight up. But if we go up 3 and go out here and up here, that's going to put a point about right there. And then we can connect that line. I didn't do a great job of connecting those lines, but it's going to look about like that.